Welcome to this edition of Curiosity Uncovered. You may have noticed that the banner's upside down, and there's a reason for that. We're going to get to it in just a minute. But today we're going to talk about things that we can't see with our unaided eye. And so we're going to talk about things very, very tiny, and you could almost say microscopic. So, of course, today's discussion is going to be about microscopes and how we view the world of the very small. So, of course, we started out with just magnifying glasses. And how this works is there's a curvature to the lens, which then bends the light rays before they hit your eyes and makes an object appear larger. There's lots of different microscopes out there and a lot of different kinds that you can use. Something very simple like this. This is called monocular because it only has one eyepiece. So you're only going to use it with one eye. Okay, so it has a 10x magnification lens here. This is your eyepiece. And then this would be your objective lens. Your total magnification that you get is going to be your eyepiece magnification times your objective lens. Also a simple compound microscope, except that here we have 3 objective lenses, so we can move back and forth between our objective lenses in order to be able to change the magnification. On a compound microscope, the image is inverted, so it's upside down. So when you're moving your specimen around, you have to move it in the opposite direction that you want it to go in, that your image is in. So it's a little counterintuitive, but once you get used to doing that, it's pretty easy. So let's talk about preparing our specimens. So we have a specimen that we prepared earlier that we're going to take a look at in a little bit. And we just went outside and took a little drop of pond water out of our turtle pond. So you take a glass slide. These are glass slides. You take a drop of your sample, you put it on your glass slide, and then we have these little tiny cover glasses. So you just take a tiny piece of the cover glass and set it on top. And there you've created a slide. Now you're going to take your slide and you're going to put it on your stage. Okay, that's the name of the area that you would put your slide in. Okay, now we have microscopes that are using transparent, taking advantage of transparent light, which means that the light source is underneath the stage. The light is going to shine through your sample, travel up the eyepiece, and then into your eye. So in something as simple as these, this has a prism that's going to collect your light. This should have a little mirror, but it's broken off. Okay, and these 2 are electrical, so they're going to actually have a light source down here. Another way that you can use microscopes is to use reflective light. And this is where the light is going to be here and is reflected down on the object, hits the object, and then bounces back up to your eye. This is where you would use reflected light if you're using things that aren't see-through. Okay, but the microscopes that we're going to use today have transmitted light. Light source is on the bottom and travels up. This particular microscope is called a binocular microscope because, as you can see, it has 2 eyepieces. Okay, so we're going to do this. Go down here, plug our microscope in, turn our light on, and then take a look at what we have. So if we need more magnification, we can always increase the magnification by changing our objective lens. If we need to get it into focus, maybe it's a little fuzzy, we can use our fine and our gross focuses. Okay, so this is going to help us move the stage up and down just a tiny bit in different increments, which will allow us to focus in on our item of interest. And in this case, it's going to be our drop of pond water. Okay, now this is a little bit fancier microscope. This is called a stereoscopic microscope. And these guys are really nice because they have a mirror in here which inverts the image. So when you're looking at it through your microscope, the image is upright. Okay, that's one great thing about this type of microscope. Another great thing about this type of microscope is it has a really large working distance. So we can move, there's a great distance here, we can move it up and down. So if we have bulkier items or things that we're trying to look at, this is a great microscope for that. As a matter of fact, the stereoscopic microscope is the most useful microscope used in forensic science. So all you Sherlock Holmesians out there, this would be the microscope for you. Now, something that you can do these days on your own without having to buy a big piece of equipment is, ta-da, there are all sorts of microscopic lenses that you can buy, and you just put them on your phone. And that way you can open up your camera app, and then you can go out there and you can use this as a magnifying tool or a microscope to help you just see things that you may come across on your daily walk. Maybe you saw a cool bug and you want to get a little bit closer look at them. These are an easy way to do that. So there's one other type of microscope that doesn't use lenses. So all of these microscopes use lenses to create that magnification, and that's called a scanning electron microscope. Now these guys are big pieces of equipment, all right? So you're not gonna have one like at your home laboratory or not even here at the Science Center. And they use, instead of using lenses and light, they use a beam of electrons. And those electrons are gonna hit the surface of the specimen, interact with it, and release X-rays. Energy in the form of X-rays, and then we're gonna capture that image. So we're gonna give you a super cute picture of one of my favorite microscopic animals, the cute and cuddly tardy bear. Tardigrade, they call them water bears, we call them tardy bears. Very, very popular, especially when looking at them under the microscope, because they're just so cute. They just run around, float around on a little bit of water, munching on some algae. Very, very cute. So you're gonna be able to see a regular microscopic picture of it using light microscopes, and then also take a look at this really cool scanning electron microscope image of it. Great detail using that scanning electron microscope. Really, really cool pictures. I would recommend Googling it because you can see a lot of really cool pictures, and we'll sneak in a couple of more of those so you guys can take a look at them and maybe guess what you think those are images of. So thanks for spending a little bit of time with us today learning about microscopes, and it's a way that we can explore and learn more about the world around us.